very first box, it says the Isosceles Triangle Theorem. And word for word, here's what it says. If two sides of a triangle are congruent, then the angles opposite the sides are congruent. So in that first box, you're going to draw an isosceles triangle. Isosceles triangles have two congruent sides. The first day of chapter 4, we drew the classification of the different triangles, and one of them was an isosceles triangle, which had two congruent sides. So you put the little tick marks on them. This theorem says that if it's an isosceles triangle and those two sides are congruent, then the base angles are going to be congruent. So angle B is going to be congruent to angle C. Okay? In the box directly underneath it is the converse of this theorem. And converse just means you're going to flip it around. All right? So we're going to draw in the box directly underneath it a second triangle. We'll label this one DEF. And the converse of the isosceles triangles theorem says that if the two angles of a triangle are congruent, then the sides opposite the angles are congruent. So on an isosceles triangle, when these two angles, what we call base angles, are congruent, then the two sides opposite them are congruent. So DE is going to be congruent to DF. So those two theorems have to do with isosceles triangles. The next box is the equilateral triangle. So on the equilateral triangle, you don't just have two sides congruent, you have how many sides congruent? Three. So here's what it says. If a triangle is equilateral, then it is equiangular. So remember the first day when we classified our triangles, we did the equilateral triangle right above the equiangular triangle, right? We kind of drew a little equal sign between them because they really end up being the same thing. So in that box, you're going to draw a triangle and you're going to put tick marks on all three sides. All three sides of an equilateral triangle are congruent, and this theorem or corollary says that if they are congruent, then the angles opposite them are congruent. So it ends up that angle A is congruent to angle B, which is also congruent to angle C. All three angles. And since we know the triangle sum theorem, that all the angles add up to how many degrees? Not 90.
I mean 60.
Not 60.
I mean,
all three angles add up to 180. Then if you divide by 3, you get the number that you already said, 60. They're all going to be 60, 60, 60. Okay? All right. So in the box directly underneath it, we're going to do the converse. The converse says that an equiangular triangle, where all three angles are congruent, then it is also equilateral. So we'll call this one DEF. We'll mark all three angles congruent. If all three angles are congruent, then all three sides opposite them are also congruent. So DE is going to be equal or congruent to EF, which is going to be congruent to FD. So both of those theorems are true, and their converses are true. So it'll go both directions for the isosceles, the sides to the angles, so the angles to the sides. Same thing with the equilateral. The sides to the angles to the sides. Okay? So you really only have to memorize one for each. And they're almost the same because this one's 2, this one's 1 more, 3. Okay? All right, let's look at some examples. Example number 1. We're going to start by drawing a triangle. We'll call this triangle DEF. This triangle is going to be an isosceles. We're going to put 2 tick marks to show that they're congruent. I'm going to give you a measurement for angle E, which is 22 degrees. On an isosceles triangle, when you have the two congruent sides, those are called legs. So this side is a leg, and this side is a leg. The third side that isn't marked congruent ends up being called a base. And those two angles end up being base angles, okay? The directions here are to find the measure of angle F. Okay? Now, normally, you're given two angles. You start with the total degrees in a triangle, you subtract those two measurements, and you end up with the one that's left over. But in this case, they only gave you one measurement. But we know from the isosceles triangle theorem that these two base angles are what? Congruent, okay? So because angle D is congruent to angle F, we can start with the 180, subtract the one angle that we know, that 22. We should have 158 left, and we do what with that number?
We then split it.
We split it, which means divide by 2. So if you take 158 on your calculator, divide it by 2, you should get 79, okay? That's the measure of angle F. It's also the measure if they'd asked you for D. They could have asked you for either, you would have gotten that same answer, all right? Any questions on example number 1? All right, move over to the example number 2 box. All right, GHJ is also an isosceles triangle, even though it's turned on its side. We're going to put our little tick marks to show congruence. But instead of giving you angle measurements, I'm going to give you some algebraic expressions. So we've got angle G is x plus 4, angle J is 3x. In this case, we're going to be asked to find what is the measure of angle G. Okay? So first we have to figure out what is the measure, or what is the value of x, and then we're going to have to plug it back in. Okay? So even though we weren't given measurements, we know that on an isosceles triangle, opposite those two congruent sides, those two angles should be congruent, which means they're equal to each other. So we're going to say that 3x is equal to x plus 4. We subtract x from both sides. We get 2x equals 4. Divide both sides by 2. So x is equal to 2. If you're only asked to solve for x, you can stop there. But if you're asked to solve for an angle, you have to plug back in. So the measure of angle G is going to be equal to 2 plus 4, which is 6. So 6 degrees. Okay? Any questions on example number 2? All right, one more box to go. Example number 3. Mrs. Hoven. Hi. Okay. I'll check in. Okay, bye. All right, so for example number 3, we have a triangle, just so happens to be a equilateral triangle, so we'll call it KLM. Equilateral triangles have 3 congruent sides, so you're going to put tick marks on all 3. And I'm going to give you a measurement for angle K, which is 2x plus 32. So I've only given you one angle measurement, and I'm going to ask you to solve for x. All right, this is an equilateral triangle, so all 3 sides are congruent, which means all 3 angles are also congruent, and they each have a measure of 60. So even though they've only told us 1, we can just use that and set it equal to 60. So 2x plus 32 equals 60. Subtract 32 from both sides. And that is 28. divide both sides by 2, and x equals 14. So on example number 3, why did they ask us to solve for x and not ask us what is angle L? Because it would have been 60, right? They all just would have been 60. You wouldn't have had to do any algebra. All right? So they're going to either ask for x or they're going to ask for you to solve for the